Hello everyone, welcome to the lecture about microcontroller unit. In today's lecture, we will talk about how to provide computation power to electronic devices. We will introduce what is microcontroller unit, MCU. We will also talk about a special type of MCU, the Arduino MCU, and how to program with Arduino. Before human beings invented computers, our brain was the most powerful computation device on Earth. Later, we invented computers, and computers are much more powerful in terms of calculation or computation. We say that because the number of additions or subtractions a computer can complete within 1 second is much higher than that we can complete by using our own brain. However, computers do not have the ability to make a logical decision. Recently, we have made certain progress, or we can call it significant programs, in this area, and we call it artificial intelligence. I'm sure you have heard the story that AlphaGo beating people in playing certain type of chess games. In this lecture, we will not talk about artificial intelligence. We will not even talk about the general computation power. The computer here has what we call general computation power because we can use it to watch a movie, to play a computer game, or even process our document. However, there are certain scenarios we need special or dedicated computation power to complete certain tasks. For example, we need special computation power to handle the radar on an airplane. We need special computation power to handle the flying of a satellite. We need special computation power to process the image from certain medical systems. And the microcontroller unit basically is the solution to provide those distributed and dedicated computation power. Now let's look at what's the difference between a regular computer and an MCU. This regular computer here has its own power source, its machine to run the programs, its input and output devices. If we look at the MCU, it also has its own power source, its place to run the program, and also its input and output ports. So from this perspective, we can regard MCU as a computer system. However, the difference is normally the computation power from a microcontroller unit is not that high. This makes sense because what we require from a microcontroller is a distributed and dedicated computation power. Look at the example here. Imagine you have a car. There are many different parts you want to control by using MCUs. Say, for example, you may need MCU to control the camera. You may need MCU to control the sensors. You may need MCU to control the collision avoidance system. For all those tasks within this car, the computation power requirement is not that high. We just need to put some distributed and dedicated, possibly weak computation power to different parts of the car to complete different tasks respectively. In fact, this is what we call an embedded system. So what is an embedded system? An embedded system is also a computer system, but with dedicated function within a larger mechanical or electrical system. And most of the time, the embedded system has a real-time computing constraints. That means the computation power is not that high. Similar to a general computer system, an embedded system also has its own hardware and software components. In fact, embedded system is the foundation for the idea of Internet of Things. Why? Because if you want to connect things together, you need to give all those things certain computation power. And the embedded system is the solution for providing computation power to different devices. In this lecture, we'll introduce a special type of MCU called Arduino MCU. We will talk about its hardware and also how to program it, that is its software part. The diagram here is what we call the IC pin diagram for Arduino Nano. You can see that there are many pins. They are used to provide power. They are used to transmit and receive information. They are used to as digital input and output pin, they can also provide analog input or output pins. In the following, we will use a sample example to see how we can use those pins and how we can program with Arduino Nano. This is a sample program which includes 3 parts: the library part, the setup part, and also the loop part. Let's first look at the library part. This section of the program includes the library files to the program. What is library? Libraries are predefined to provide some commonly used functions. For example, you are using Arduino to control a motor. It's better you can define some functions called motor start and motor stop. So in the future, when you want to start or stop a motor, you can directly call that function. In order to use that function in your program, you need to include them at the beginning of your program by using the command include. For the above example, we do not need any library, so we use the comment operator. Basically, the double slash is the comment operator, and anything follows it will be regarded as comment, so that the two commands include communication.h and include motor control.h are not executed. In your project, you may need to include your own library files. Now let's look at the second part, which is the second setup section. This section of the program will set up or initialize Arduino. Basically, it will be executed whenever we start or reset the Arduino board. The function we used here is the pin mode function with 2 inputs, index and mode. It will configure a specified pin indicated by the index input to behave either as an input or output pin. Index here denotes the index number, and in total there are 14 digital pins ranging from 0 to 13. And the mode here denotes the operation mode of that pin. Basically, we will specify whether that pin will work as an input or output pin. The above example initializes pin 13 to be an output pin. Now let's look at the last section, the loop section. This section of the program controls the board with the defined operations. The loop routine will run over and over again until we power the Arduino off. There are 2 functions we used for this example program, namely digital write and delay. In the following, we will first look at their respective functions and then see what is the function of the whole program. The first function is called digital write with 2 inputs. The first input is an integer type pin number input. It ranges from 0 to 13. Basically, we can use digital write function to all 14 digital input or output pins. The second input is a Boolean value input. What is a Boolean value? Basically, Boolean algebra is the foundation of modern computers, and it only deals with 2 values. Normally, people call it high or low, true or false, or 1 or 0. So the Boolean value input here can only take one of the 2 values, either 1 or 0, either high or low. The function digital write will output one of the 2 Boolean values, high or low, or 5 volt or 0 volt, to one of the pins specified by the input pin. We call it digital write because it only writes one of the 2 Boolean values to the pin. Besides digital write, we also have a function called analog write, although it is not used in the example program. Let's look at the function of analog write. Analog write also has 2 inputs, an integer type pin number, but the pin number here can only take value from 6 out of the 14 digital pins. They are 3, 5, 6, 9, 10, 11. And basically, those are the digital input or output pins with dot on top of the pin numbers. The second input is an integer type value, which takes a value from 0 to 255. The function of the analog write is to output a pulse signal to the specified pin. And then what is the function of the integer value? Basically, this integer value will control the duty cycle of the output pulse signal. Or on the other way, we can see that the integer value here controls the power from the pulse signal output to that pin specified by the first input. The second function used here is the delay function, which only takes one input. The input is an integer type time value. The range of this value is from 0 to a very large number, and because the unit is millisecond, that very large number corresponds to 1193 hours or 49.7 days. The function of delay is to pause the program for a given amount of time, and it is normally utilized together with loop to achieve a periodic operation. Now let's look at the function of the whole program. In the library section, we did not include any library files. In the setup section, we initialized pin 13 to be an output pin. The routines from the loop section will keep running over and over again until we power the Arduino off. There are 4 lines within the loop. And the first line, digital write 13 high, will output a high voltage to pin 13. And because pin 13 is internally connected to an LED, this function basically will turn that LED on. Then the delay 1000 line will pause the program for 1 second. And then digital write 13 low will output a low voltage to pin 13, which will turn the LED off, and then the program will pause for another 1 second. Because the routines here will keep running again and again, what we will observe is the LED will be on and off and on and off forever, and we call it the flash program. Okay, that's all for today.